We're going to talk about percent composition. And this is useful sometimes. So we need to know the general idea of percent. Percent is the part that you're interested in divided by the whole thing times 100. And the unit ends up being percent. Because generally, however you measure the part is the same way you measure the whole, and the units cancel out. So if we're talking about the mass percent of element X in a compound, X is what we're interested in. So we're going to have the mass of X in whatever sample we have divided by the mass of the whole sample. The part over the whole, and then multiply by 100 to get a percent. So in a situation like this, you cannot have more than 100%. Just like, well, the analogy I use a lot for percentages is my oldest son, when he was in kindergarten, there were 20 students in the class. 15 of them were boys and 5 of them were girls. And so you can calculate the percentage of boys, the percentage of girls. It ends up 75% boys, 25% girls. And if you've, been around 5-year-old boys, or if you remember being a 5-year-old boy, you know that that's a lot of boys. It's a lot of boys. But if you did a calculation and you came up with 115% of the class is boys, is that even possible? No, it's not possible. That's like saying in a class of 20, there are 27 boys. Doesn't make sense, right? So when you do these problems, sometimes, we get lost in the forest. We see we're in the trees and we see them. Sometimes you have to step back or get in an airplane and fly over and look at the big picture and ask yourself, am I just being crazy here? Am I doing stupid things? Or is this actually possible? So when we calculate a mass percent of an element, it's always going to be less than 100. When we have percent error, we can have greater than 100% error, which means that it was really bad, more than 100% error. But in a situation like this, we can't have more than 100%. So we need to keep in mind what percent means, part over whole times 100. So here's an example. 2.45 gram sample of strontium reacts with oxygen to form 2.89 grams of strontium oxide. Use this data to calculate the mass percent composition of strontium in strontium oxide. So it's asking us for mass percent. So we need to remember that percent is the part over the whole times 100. So here what we have is we've got strontium and we're reacting it with oxygen and we're going to form strontium oxide, and we're not going to balance that or do anything crazy, but just kind of a picture to help us see what's going on. Here's one part and here's another part, and they go together and become the whole thing, right? This is the whole, and we're told what the mass of the whole thing is. It's 2.89 grams. And we're given the mass of strontium that was used, 2.45 grams. So to find the percent strontium, we're going to put the mass of the strontium, the part that we're interested in, divided by the mass of the whole thing. And then we're going to multiply by 100%. 2.45 divided by 2.89 times 100. And this should have 3 sig figs, 84.8%. So strontium oxide by mass is 84.8% strontium. This is a straightforward problem. They gave you the mass of a part and they gave you the mass of the whole. You just have to plug them in. Sometimes they'll give you the mass of both parts, or they'll give you the mass of the whole and the mass of the wrong part and make you figure it out. Percent composition can be used as a conversion factor. And it's really quite a convenient conversion factor. So we're told here, the mass percent composition of sodium in sodium chloride is 39%. We would calculate that, or we could calculate that by looking at the formula. But that's not what we're looking at yet. 39%. Percent also means per 100. So that means 39 grams of sodium per, okay, this is not going well. I want this to be vertical. 39 grams of sodium per 100 grams of sodium chloride. Any percent means that. So in James's kindergarten class, 75% boys means 75 out of 100. A percentage is going to be the same no matter how big or small the sample size is, and that's one thing that's useful about it. So if you had a larger class, you could use the percentage to figure out how many boys and how many girls were in that class if the percent of boys was the same. But anytime you see percent, it's per 100. So that can be used as a conversion factor. So circling back to that question, FDA recommends that adults consume less than 2.4 grams of sodium per day. How many grams of sodium chloride can you consume and still be within the FDA guidelines? Well, if we know this percent sodium, we can calculate this. 39% sodium. So 2.4 grams of sodium, and we want to know how many grams of sodium chloride would you have to eat, or could you eat, to get that much sodium. So we have sodium chloride on top and grams of sodium on bottom, because we want the units to work out. Remember, 39% means 39 grams of the thing that you're interested in, the part, divided by 100 grams of the whole thing. So that means that 39 goes on the bottom, 100 goes on the top. 2.4 times 100 divided by 39. 2.4, 2 sig figs, 6.2 grams of sodium chloride. If you consumed 6.2 grams of sodium chloride, you would get 2.4 grams of sodium. The rest of the mass is made up by the other element that's in that compound, the chlorine. Any questions? So just beefed up dimensional analysis problems. And you can't say I didn't warn you.